Today we're going to be talking about how to apply Venn diagrams to understanding the idea of probability. Now you guys are probably familiar with Venn diagrams in the context of history and English, but in fact a Venn diagram is a mathematical concept, and we'll discover how that relates to math after we're done with our warm-ups. So go ahead and give these a shot, pause the video, see what you come up with, and then push play and compare your answers to make sure you're right. If you are not getting these questions right, you need to be coming to the Zoom meeting so that you can make sure that you understand what's going on here. So go ahead and pause the video. Okay, for number one, it says determine the probability that a tablet is a 16 gigabyte tablet. That's the meaning of this. The probability that a tablet is a 16 gigabyte tablet, okay? Or the probability that somebody purchased a 16 gigabyte tablet. The first thing I need to do is I need to finish out this table by putting the totals in. And so our totals for 16 gigabyte are going to be these two added up, so that would be 170. The totals for the 32 gigabyte would be 105, all right? The totals for the classic tablet would be 117 because we're adding those two up, and the classic or the tablet mini is 158. Now to double check your work, you're going to want to add these two numbers. You get 275 for the total, and you want to add these two numbers to make sure that those add up to the same value of 275. So now we can figure out the probability of a 16 gigabyte tablet, and so when we set up that probability, how many of these things are 16 gigabyte? Now you can go through piece by piece if you want, or you can look at the totals if you want. I like doing piece by piece and asking myself, does it fit the requirements of what's said in the problem? So is this group a 16 gigabyte? Yes it is. Is this group? Yes it is. Is this group? No it isn't. Is this group? No it isn't. So these two are our 16 gigabyte tablets, so that adds up to 170. So that is going to be our event space, that's what we want, and our sample space is going to be the total of 275. And then you can convert that to a percentage or a decimal and reduce or whatnot, but we're just going to leave it for there. If you got that and then you simplified it, I'll assume that you're right. Number two, we've got this symbol here. We talked about this last time. What is the probability that a person purchased a mini and a 32 gigabyte? Well, what does that mean? That doesn't mean they bought two different tablets. That means they bought a tablet that is a mini tablet and it is a 32 gigabyte. So again, going through these pieces, is this a mini and 32? No. Is this a mini and 32? No. It's a mini, but it's not 32. Is this a mini and 32? No. Is this a mini and 32? The answer is yes there. So our probability is 63 out of the total, which is 275. For number three, it's saying what is the probability that a person purchases a classic tablet or a 32 gigabyte tablet? So a classic or a 32. Again, going through the motions here helps us understand what we're looking at. Is this a classic or a 32? Yes, it is. It's a classic. Is this a classic or a 32? No, it's not. Is this a classic or a 32? And this is where students get confused. Well, it's a classic and a 32, so it's not classic or a 32. Yes, it is. It just has to meet one of the requirements at least. When you hear the word or, you think in your head and or. Okay, so it's either and or. It's got to be one or the other or both. So this is a classic or a 32. Is this a classic or a 32? It's not a classic, but it is a 32. So we're going to include these three pieces here. And so we add those up, we end up with 180 and then out of 275. What you're going to see as we go through the lesson, because we're going to talk about more intersections and unions today, but we're going to look at it through Venn diagrams, it's going to be the same type of thing. Notice when we're talking about we're talking about a very specific one box or one piece of the puzzle. Remember, it was just the 63. When we're talking about or, we're talking about 3 pieces of the puzzle. So you can always check your work if you just have a basic table where you're comparing 2 different things. You can always check your work. If you have an and statement, you will have 1 item identified. If you have an or statement, you will have 3 items identified. With that said, let's go ahead and get into our lesson. Our goal today is to be able to interpret a probability experiment using a Venn diagram. Now, like I said before, a Venn diagram is used in a lot of different things. You guys are used to the idea of comparing and contrasting things, right? But we could go a little bit deeper in this and say that a Venn diagram is something that shows how multiple things are alike and how they're different. Or it's the set of things that certain ideas have in common and the set of things that the ideas don't have in common. And so here is a Venn diagram in respect to numbers. And this Venn diagram shows how many students are taking Spanish and art. Okay, so we're not talking about math and English and all that. We're just comparing Spanish to art. Now we can get more complicated Venn diagrams, but really what we're going to focus on in this unit, in this year, is Venn diagrams that only compare 2 different things. Those that take Spanish and those that take art. Now you can see in this Venn diagram here the relationships. Now I want to go through each of these and we're going to talk about each one of them as we go through this, but notice that there are 4 pieces. There is the moon, if you were to shade in this 112, that would be the moon. We have another moon over here, right, 98, and we have this football shaped thing. And then this 56 represents everything that is outside the 2 circles. So the 84 is where they overlap. I'll probably refer to that as a football sometimes. That's the intersection. And then the 112 and the 98 are moons. We're going to talk about, those are basically the isolation. So this group is the group that only takes Spanish. In other words, this group is not taking art. They are taking Spanish. And this group is the ones that are only taking art, which means they're not taking Spanish. With that said, let's go ahead and go through what each of these values mean. The 112 here represents, we just said it, the number of students that are taking Spanish and are not taking art. Okay? So the students that are taking Spanish but are not taking art. The 98 represents the amount of students that are taking art but are not taking Spanish. It's pretty straightforward. The 84 is the amount of students that are taking Spanish and art. So they're taking both of the classes, right? So notice the word and. They're taking Spanish and art. Well, how many things did I say when we talk about the word and? We're talking about 1 piece of the Venn diagram. 1, 2, 3, 4 pieces. When you hear the word and, it's 1 piece. The 56 is the amount of students that are not taking Spanish or art. They're not taking either class. Now, we can add to this Venn diagram 2 lines, and I think this is beneficial. If you notice here, I drew 2 lines that are going down from the circles. Normally, we don't see a line in a Venn diagram, but this helps us understand what's going on with the Venn diagram. If we want to know the total amount of Spanish students, we would add these 2 numbers together because this group of 112 is taking Spanish and this group of 84 is also taking Spanish. So when I add those together, I get 196. And as a result of that, we can say that there are 196 students that are taking Spanish. We're not talking about comparing art and Spanish here. We're just saying that there were 196 that took Spanish. Well, how many students took art? Well, some students would say, well, 98 students took art. That's true. These 98 did take art. But did this 84 take art? Yes, they did. So we'd add those 2 numbers up and put them at the bottom of these lines, and these numbers represent the amount inside the whole circle, where the 98 only represents the amount inside this moon shape here, and the 84 represents the amount in the football. The reason I'm pushing this issue is because a lot of students make errors when they are filling out a Venn diagram based on what is being said. If I say there are 98 students that take art, then we do not put the 98 here. We put the 98 down here because there are 98 students that take art. So you have to include both pieces of the art circle, okay? Here we're saying there's 98 students that took only art, and that's key. If I say there are 98 students that took art, it goes down here. If I say there are 98 students that took only art, it goes here. So the word only implies inside the moon, where if I just say there are this many students that did this, then that's going to go down here. All right, let's go ahead and take a look at some practice problems with this, some examples. Same concept. We're comparing art students to Spanish students, both and neither. If a student is selected at random, what is the probability that they take Spanish? Well, how many students took Spanish here? The 112 took Spanish, the 84 took Spanish. That means there were 196 students that took Spanish. So we would say there's 196 students. We'd add those two numbers up out of the entire amount. So we're going to add up all the numbers inside the Venn diagram. Now I want to point out the 196 and 182, you wouldn't want to add these two guys up, because if you add these two guys up, you have an overlap here, right? If you add these up, you're counting the 84 actually twice. So what you can do is add up the numbers just inside the Venn diagram, the four pieces, the 112, 84, 98, and 56. And so our sample space is 350 here. Now, a side note, and I think that this is beneficial, if we add a number on the outside here, if I put 350, and I know it's kind of weird place to put it, but we're going to put 350 outside the Venn diagram. And what that represents is a number for the total amount inside the box. When I simplify this, I end up with 56% if I'm rounding it. Looking at number 2 here, it says, what is the probability that a student is taking art? Well, how many students are taking art? There's 182 students taking art, and the reason I know that is because I add the 84 and the 98, which I already did by putting it in the space below the line. So it'd be 182 divided by 350, because that's the total amount, so which is 52%. Now, you might say, how is that possible? Because there's 56% that play sports and 52% that play sports in our different concept. There's 56% that are taking Spanish and 52% that are taking art. When you add those up, you get greater than 100%. Well, that's because there are certain students that are taking both classes, right? And so this is including the students that are taking both, and this is also including the students that are taking both. So you have to be careful on how you're answering these questions. All right, next question. What is the probability that a student is taking neither Spanish nor art? So we are looking for the region of students that are not taking either class. Well, is this student taking Spanish or art? Yes, they are. Is this one? Yes. Is this one? Yes. Is this one? No. So our total students that are taking neither class is 56 out of 350. And notice the notation here. We'll get more into this in a minute. The probability that students are not taking Spanish and not taking art. Remember, in the warm-up I said if you hear the word and, you're thinking one region. Well, there's 4 regions here. 56 is one of them. If you see and, you're thinking one piece of the puzzle. 56 is one of those pieces. And we end up with 16% here. All right, let's go ahead and take a look at the next question. What does this mean? So we're not looking for probability anymore. I'm just asking what it means. This is the probability that a student is taking Spanish and art. Well, there's the word and again, so we're thinking about one piece of the puzzle. Which piece is Spanish and art? Well, this is not Spanish and art, it is just Spanish. This is Spanish and it is art, so this is the piece here. This is just art and this is neither. So we would be saying this piece, the 84, and notice it's one piece out of the 4 pieces that make this up. So the probability that the student is taking Spanish and taking art. And again, remember the symbol and, another word for that is intersection. All right, so that piece there. And then if we're figuring out the probability, it'd be 84 out of 350, which is 24%. All right, let's take a look at one more problem here. What is the probability, and what's this mean? What's the probability that a student is taking Spanish or art? Spanish or art. Well, remember in the last frame, in the warm-up, I said when you hear the word or, remember what's the other word for that? That's union. When you hear the word or, you're thinking 3 pieces of the puzzle. Okay? So is this group taking Spanish or art? Yes, they are. Is this group taking Spanish or art? Yes, they are, because they are taking both. Remember, the and is part of the or. Is this group taking Spanish or art? Yes. Is this group taking Spanish or art? No, they're taking neither. So we are looking at these 3 pieces to make up our or. Remember, or represents 3 pieces. So it's that one, and it's that one, and it's the overlap of those. Remember, you don't want to include the inside of that twice, so you would only count it once. And again, this is the probability that a student takes Spanish or art. And that would be 84%, because that would be 112 plus 84 plus 98, and then all over 350 is our total. All right, let's go ahead and take a look at set notation. This might help us understand a Venn diagram a little bit more when we talk about shading. So remember this concept. When you hear the word intersection, that symbol is and. It's the N basically, or the upside down U. Okay, A intersect B, we would say. This is the subregion that 2 regions have in common. So if I was to draw a Venn diagram of A and B overlapping, we are looking for the piece that is both A and B. Again, when you see and, you're thinking one piece of the puzzle. There are 4 pieces. There's the moon, the football, the leftovers. The moon, the football, the leftovers. When you hear the word and, you're thinking one of those pieces. So in this case, it's the intersection of A and B. Okay, union, remember, this is union. We use the U to represent union. So A union B. And this means the subregion, right, or the regions made by combining 2 regions. So if I drew a Venn diagram again, we're looking at the pieces that combine to make either A or B. And so like I said before, when you hear the word or union, you're thinking 3 of the pieces. So here's 1, 2, and 3. Is this A or B? Yes, it is. Is this A or B? Yes, it is. Is this A or B? Yes, it is. Is this piece outside, the leftovers, A or B? No, it's not. Okay, with that said, remember complement means not. It means the region that is not in the region that we're talking about, or in the given region. So if I say A to the C, I'm really saying what is the region that is not A. So if I'm creating, or the complement of A, or not A, if I'm creating a Venn diagram of this, and again, let's say we're comparing A to B, I just like having this play out. It's kind of satisfying to watch it color in, so we'll wait till it's done. But if I'm looking for the region that is not A, I'm looking for everything in my Venn diagram that is not in the circle A. So we need to make sure that we are not including anything inside of the circle A. All right, here's some practice for you. I've got 4 different problems here, and what I want you to do is I want you to draw a Venn diagram just like this, okay? And I want you to shade in the region that is represented by each of these. So you're going to have 4 separate Venn diagrams here. Do not try and shade in one Venn diagram for all 4 because it's just going to get messy. Draw a Venn diagram for each one and shade in the region that it's talking about. Pause the video and do that, and when you're done, come back and compare what you got. For number 1, it's saying what is the region that is both B and not A. Remember, when you see the word and or intersection, you're thinking about one piece. So what is the piece of the Venn diagram that is in B and not A? And you can see that here. This one piece is B, but it is not A. If you see intersection, what you can think of is this. You can think of shading in the B, and then erasing the part that is in the A, I guess, because we don't want A, we want the not A, so it's just that here. For number 2, we're talking about the union of two things. Remember, when we talk about union, we are shading in 3 different pieces. So if I'm looking at A, I'm going to shade in all of A, and I'm going to shade in all of the piece that is not B. And so we can see in this Venn diagram here that we have A completely colored in, and then we have everything outside of B colored in. So basically, if you see the word union or here, you're shading in both of these pieces. You're shading in the piece that is A, and you're also shading in the piece that is not B. For, again, for the intersection, you're going to be erasing pieces. So you're only shading in the piece that both of these have. So one way of looking at it, and I'll do this real fast so you can see it, just in case you didn't get it. If I were to shade in B, that would be this piece here, okay, all of this, right? And then if I were to shade in the not A, that would be everything outside of A. So it would be all of this, because we don't want to include A, and then all of this, right? All of this that's outside of A. So you can see that in fact, the part that is shaded for both B and not A is the part that both red is colored in and blue is colored in. And so you can see as a result of that, that this piece, I know this is getting really messy here, this piece, this green piece, is the only piece where both of them are shaded in. And that's why we ended up with just that yellow piece originally. So let me go back to that, just that part. For number 3, we are looking for the intersection of not A and not B. Remember, we're looking for, when we see intersection, we're looking for one piece. So if you shaded in the region that's not A with one color, and shaded in the region that's not B with another color, the answer would be where both of those shades are filled in together. So the region that have both colors in them. But again, you should only have one piece, and in this case, it would be the piece that is outside of A and B altogether. So we don't want to count A or B here. And so you can see, once it's done, that it's the outside piece. Again, if you hear and or intersection, it is one piece of the puzzle. Remember, there's the moon, the football, and the leftovers. In this case, it's just the leftovers. Here we're talking about the union of not A and not B. So what are we thinking about when we think union? We're thinking 3 pieces. Well, what does this look like then? If I were to shade in, and I'll do this on this piece here. Let's see if I can do this a little bit clearer. Let's change the color tone a little bit. If I were to look at the piece that is not A, the piece that's not A is everything out here. Okay, I'm just shading in this one before. This is not the answer to number 3. This will be the answer to number 4. This is not A, okay? If I were to shade in not B like it's asking me to, not B is everything that's not touching B, so it's all of this, okay? So not B. When I'm talking about the union, I'm looking for basically anything that is shaded not A and anything that's shaded not B. So basically, if you see union, you are looking at anything that's colored at all. So let me go ahead and put that answer here. That would be anything that has any color. So it could be blue or red here. And so you can see the only thing that doesn't have color is the little football inside for number 4. So again, just to kind of recap, when you're talking about intersection, what you can do is shade in the pieces that it's talking about, and the intersection is the piece that has both colors in it. Okay? So that's why in number 3, it was just the outer piece, because you had blue and red in the outer piece. But in number 4, when you're talking about union, we're talking about anything that's colored in along the way. So the only thing that's not colored is the football here, and that's why we ended up with number 4 being that. Let me go back and erase this so we can, let's see here. So you can compare those two side by side. Oops. Okay. So there's our answers there, and if you need to, stare at that for a minute to make sure you're good with it. Let's go ahead and take a look at one last problem here. A player will be selected at random from a baseball team. The Venn diagram shows the number of right-handed players and the number of pitchers. So this circle represents the number of right-handed players, and this circle represents the number of pitchers. Now the first thing I want to do here is finish the Venn diagram, and some of you might go, well, the Venn diagram already has numbers in every piece. That's true, but remember, if you can draw those lines going down, those lines, the numbers at the bottom of those lines represent the totals in each circle. So what number goes down here? Well, it would be the sum of 18 and 9, which is 27. What goes down here? It would be the sum of 9 and 6, which is 15. And then remember, we have one more number, and that is the total of the Venn diagram. So what we're going to do is we're going to add up the 18, the 9, the 6, and the 7, and we get 30. So there's a total of 30 players all together here. All right, looking at this chart, let's kind of go through and answer each one of these pieces as I put them in here. So probability in words says, what is the probability that a player is right-handed? Well, how many of them are right-handed? Is this right-handed? Yes. Is this? Yes. Is this? No. Is this? No. So we have 27 out of 30 as our probability. Sorry, out of 40. Where did I get 40 from? Let's see here. Did I add that wrong? I did add that wrong. That was supposed to be 40 here, so let's go ahead and fix that. Okay. All right, so that's 40. Now, that would be 67.5%. Going back to the probability notation, this is just a single event probability. The probability of right-handed. Notice, it's kind of cool here, when you have a single event probability where there's only one letter here, notice that we are including two pieces of the puzzle. Okay, so again, when you have and, you're thinking one piece. When you have or, you're thinking three pieces, right? You're going to add up three pieces of it. But if you have a single event, you're thinking two pieces of it. All right, next one. The probability that a player is a pitcher. The probability that a player is a pitcher. Well, the pitchers are represented by Q, so the probability notation would be P of Q. Well, how many are pitchers? That would be 9 and 6, which is 15. And again, single event probability here, only one letter, one thing, so we're thinking two pieces here, 9 plus 6. And then that would be 37.5%. The next one, it gives you the probability notation, and it wants you to write the probability in words and then figure out the probability. This is the probability that a player is right-handed and a pitcher. So let's fill that in. Probability that a player is right-handed and a pitcher. Now, what is that probability? Again, you see the word and, so we're thinking one piece of the puzzle. So what part is R and Q? Is this R and Q? No. Is this R and Q? Yes. Is this R and Q? No. Is this R and Q? No. So it's just the 9 out of the 40, which is 22.5%. For the next one, this says, what is the probability that a player is not a pitcher? Not a pitcher. Again, this is single event probability. We're just looking at the piece that's not a pitcher. So if we think single event, we're thinking about two things. Is this not a pitcher? Yeah, these aren't pitchers. Is this a pitcher? Yeah, it's a pitcher. Is this a pitcher? Yeah. Is this a pitcher? No. And so we would say, again, this is the probability that a player is not a pitcher. We would say the 18 and the 7 are the pieces that are not pitchers. So it'd be 25 out of 40 or 62.5%. And the last one, it says, what's the probability that a player is right-handed and not a pitcher? Now this one, it's a little bit more complicated because of the word not. But if we understand the intersection is one piece of the entire puzzle, let's identify the one piece in the Venn diagram that has the right-handed players and not the pitchers. Well, is this a right-handed player? No, it's not, so we don't want that. Is this a right-handed player? No, it's not. Is this a right-handed player? Yes, it is. Is it a pitcher? It is a pitcher, but we want the piece that's not pitchers. Is this a right-handed player? Yes. Is it a pitcher? No. And so that's exactly the piece we want. So it's 18 out of 40. Again, because it says and, we're thinking one piece, so it's only the 18, and so that's 45%. All right, that wraps up this lesson. I know that this was a long one, but hopefully you followed it. Make sure you answer the questions in the spaces below, and if you have any questions, make sure you log into Zoom, and I'll see you again next time.